Now we have reached to the gametophyte generation. Okay. So like Lycopodium, no, when the spores germinated, when the haploid spores germinated, and they gave us those different types of gametophytes. Remember, we had the clavatum type, phlegmaria type, cernum type. Okay. So even in your assignment, I gave that question. So you write those three types and you draw them. Okay, so in the gametophyte, when we talk about the gametophyte generation, so the spore is the first cell of the gametophyte generation. Okay, if this is the spore that has already come out, okay, this is the microspore. Okay, let's say this is the microspore. Now when this microspore will come out and germinate, this microspore is the first cell of the gametophyte generation, means all these plants will be haploid. Okay, the sporophyte is 2n and the gametophytes are n. Okay, so the haploid spores, they germinate to form the endosporic gametophyte. The development of the microspore and megaspore, they start while they are still inside their respective sporangia. Therefore, the spores are shed at the multicellular stage. So let's look at the male gametophyte. The microspore will germinate. So I think you have guessed, from the small spore, the microspore, we will get the male gametophyte, and from the big one, the megaspore, we will get the female gametophyte. Okay, so the small one, the microspore, will germinate to form the male gametophyte. The first unequal division in the microspore results in the formation of a small lenticular prothallal cell and a large antheridial initial. Okay. So seeing from the diagram, let's see. Okay. After being shed, no, here, they will divide and we will get a big, okay. So this is, they have opened up the microspore. Okay. So here on opening this microspore, you see a big antheridial initial, this big cell, and one small prothallal cell there. Okay, the small one is the prothallal cell, this small one, and the big one is the antheridial cell. Okay, so it's easy from the diagram, no? Then see, the antheridial cell, they will divide again and we will get the first jacket cells. Then again, from another way, they will divide. Anticlinally, they will divide and we will get the archaeosporial cells. Okay, 1 minute. We'll get the antheridial cells. Then again, they will divide and we will get some more jacket cells. Then a third layer of jacket cells, fourth layer of jacket cells, and then we see some androgonial cells, and then at last some sperm mother cells, which will give rise to the sperms of the antherozoids. Okay. So altogether, how many layers of jackets? There are 4 layers of jacket cells. This is the first jacket cell, then first jacket cell, then second jacket cell, then third, then fourth jacket cell. Okay, and in the middle, this middle one, these are the androgonial cells. The androgonial cell will give rise to the spore mother cell, which will give rise to the antherozoids via meiosis. Okay, so the diagram looks complicated, but it's easy actually. They are just cut it open, and the sharp one, no, this one you are seeing, this sharp crown, this is the exine. Okay, this sharp one is simply the exine. So the diagram is not as tough as it looks. It's very easy once you understand. So we get one small prothallal cell and a large antheridial initial. Then the prothallal cell will not divide anymore, and the antheridial initial will divide to form true primary antheridial cells. The upper 2 cells will divide anticlinally, forming 4 antheridial cells, and the lower cell will not divide anymore. Okay, so from the diagram, so we will get the first jacket cells, and of the antheridium. Then the antheridium cells near the protalal cell will divide to form small cells and two inner cells. The other two antheridial cell will divide to form distal cell and proximal cell, which will again divide to form the outer or the fourth jacket cells. Thus, at this stage, the gametophyte has 13 cells. That is 1 protalal cell, 8 jacket cell and 4 androgonial cells. So, at this stage, it is pushed out. So, at the 13 cell stage, the male gametophyte will be pushed out of the sporangium. Okay. After shedding, the 4 primary androgonial cell undergo several divisions, forming 128 or 256 androcytes. Okay, those androcytes or these sperms. So they will metamorphose into a biflagellate sperm, which on disintegration of the jacket cell will rupture and the spore wall along the triradiate ridge are liberated. The antherozoids, they are free swimming type and they are around 15 to 50 micron meter in diameter. Then the length is about 30 micron meter in length. The sperms of Selaginella are the smallest among the vascular plants. So this is one good GK. The sperms of Selaginella is the smallest among the plants which have veins. Since all of this is happening inside this sporangium, no, this is the ligule, this is the all of this is happening inside here. So that's why we'll call it as endospore. Okay, means inside. So you don't need what is easy for you is you can practice first the diagram and then you explain in your own words, okay, how the division occurs. Because just by hearting, no, you will confuse yourself. So you practice these diagrams, you practice this way, you say horizontal. If it divides this way, you say it's vertical. You can use those words. You don't have to use anticlinal, periclinal. If you get confused, simply you say horizontally it will divide, or vertically it will divide, or transversely or diagonally. Okay, so you can say diagonal, you can say horizontal, you can say vertical. So don't confuse or scare yourself just because it looks tough. Once you understand this diagram, no, you just explain in your own words, okay, how it divides.